Number 4, convert the following word equation into a balanced chemical equation. Aluminum metal plus copper 2 fluoride reacts to yield aluminum fluoride and copper metal. So here we go. Now, copper metal, you're thinking, oh, what state of phase should this be? And it's a legitimate question. Before you say like, oh, metals are solids, they're not always solids. What temperature are we talking about? Is there any indication about what temperature that this reaction is happening at? No, there is not. Furthermore, in addition to like, yeah, it could be really hot and these could be liquids. In addition to that, what about mercury? Mercury is a metal and it's a liquid at room temperature. So what state of phase are we dealing with here? We have to be specific because chemists deal with a lot of things that aren't normal as far as us high school students are concerned. Metal is really simply referring to a sample of that aluminum. So what this ends up telling us that we can do is aluminum solid plus copper 2 fluoride. The Roman numeral 2 indicates that this copper has a +2 charge. So we're going to go Cu. And for the fluoride, I know that fluoride being in the main group 7 has a -1 charge. So I'm going to need 2 of those to balance out the 2 positive charges from the copper. React to form aluminum fluoride. I know I need to have 3 fluorides in order to balance out that aluminum, because in the same way we can know aluminum's charge is a +3. And copper metal. Now in the same way that we identified that aluminum metal means aluminum solid, copper metal means copper solid. All right, let's go back through here. We have copper fluoride in the aqueous solution, and we have aluminum fluoride in the aqueous phase as well. So here we have the formula equation, but it's not balanced yet. That's not what makes it a chemical equation. So I have to go back and balance the atoms. Right now, aluminum's a balance, so I won't worry about those right at the moment. I even look at coppers and see that they're balanced at the moment, so I'm not going to worry about that. I'm first going to look at the fluorides because they're not balanced. Okay, they're not balanced. And so I'm going to throw a 3 in front of copper 2 fluoride and a 2 in front of aluminum fluoride, so that at the end of this I'll have 6 fluorides on either side. But that doesn't just affect the number of fluorides on each side of the reaction arrow, it also affects the number of coppers on the reactant side and the number of aluminums on the product side. So I'm going to have to adjust these lone metals, which is easy enough. I have 3 coppers on this side, so I easily put a 3 next to copper by itself. I have 2 aluminums on the product side, so I easily put a 2 in front of the aluminum that's by itself. That's why in the notes we suggested that you always leave these species that are alone, leave them last, leave them till the end, because they easily pick up the slack to other more complex changes you've made. So balance the binary complex molecules before you balance the lone ones.